Hello, my name is Paul from Pro-Eye Communications and Security Systems, and I'm working with PowerTech Telecommunications in the design for the proposed mobile coverage solution, Prince of Wales Hospital in Randwick, New South Wales. So what you can see here is our first heading page, which is the site analysis. So I've given a quick summary about the building site, where it's located and what networks we're going to cover. So the proposal is based on Telstra, Optus and Vodafone mobile phone signals to be relayed inside the building. So I'm just going to scroll to the next page. So what we've done here, I'm just going to zoom in, is we've done a path profile analysis. So we can see that's the subject site there, the hospital, and there's our neighbouring network cell. These are the frequencies. I'm not going to go into too much detail. That can be done later in consultation with Pro-Eye and PowerTech. So in summary, the network cell is only 100 meters away, so it's going to provide a lot of dominance. So I'll show you what I mean by dominance as we go through the pages. And then we've got about another 3 other network cells in the surrounding area that I've also marked up, so we can have a look. We've actually got clear paths to each of these network cells. However, given the proximity of the main one, which is only 100 meters away, that should provide good dominance. So we can have a look at this one, for example. It's 145 meters away. There's another one 439 meters away. There's another site 454 meters away. So the only one that may give us a little bit of problems is the Children's Hospital, IBC, but that's in building coverage. So when we look at that, in building coverage means it's network coverage inside the building, so I'm not really too fussed about it. Okay, we go to the next page. This is the site analysis of the surrounding cells. So as I zoom in, Prince of Wales Hospital is here with the marker Bs, and there's the network cell. And I'm going to show you a live preview in a second of this is Google Earth. So I'm just going to bring that up now, and there we go. So there's our surrounding cells. Okay, I'm going to zoom in. All right, and there's Prince of Wales Hospital, where I've got the marker. Now I'm just going to turn on the patterns. So there's Telstra. So you can see it's quite close. Even though the radiation pattern from the antenna is pointing away, given the proximity, that's just going to blast right through. So they're all the Telstra frequencies, and I can turn them on and off individually, and you'll see them disappear. So even though it looks the same, if I click the first one, 700 megs, click on it, you can see it's going to be providing 700 meg signal there. Unclick the band 700, click on 850, it's the same thing. So given the proximity, for Telstra, it's not a problem. Now we move on to Optus. It's pretty much a very similar pattern. It's actually closer to the subject site, the radiation pattern. It's 900 meg, which is omnidirectional, 1800 meg, 2100 meg, and then we've got 26, which we're not going to be using inside the building because it's too lossy for this type of network that I've designed. Then we've got Vodafone. So there's 850 meg. We're not going to be using 850s. Our repeaters don't relay 850 meg, but we'll go to 900. There we go, omnidirectional pattern. 1800 meg, so 4G. And 2100 meg. Okay, so, and just to show you also on this, we can also do a quick measure. That's 103 meters approximately. Okay, just minimize that screen now. All right, so back to our diagram. So they're the surrounding cells. And what I've done is also, those images that I just showed you, I've also copied and pasted them into this diagram. So that's the Optus, and I've also illustrated the frequencies that we're going to be relaying inside the building. There's Telstra. There's Vodafone. Okay, now we've got the markups. So given that the building's quite large, I've undertaken measurements, and it was about 70 by 67 meters. So what we're basing the install on is putting 2 repeated clusters on the north end. So we've got here CL1, CL2 in the comms room, and we've got 4 main trunk cables that come out of each cluster, and they'll actually serve up to 4 antennas. But given the design, 4 antennas is quite far, so what we've done is we've broke it up into 2 areas. So we've got the northern area, and that'll feed these clusters. So you can see, for example, the blue line comes out and it feeds 2 antennas from that trunk. There's another trunk there, another 2 antennas, and another 2 antennas, and there on. And then to the right, we're feeding 2 antennas, the first part. Second part, there's another 3 antennas, another 3 antennas, and then 3 antennas to the farther right. Then we go to the south end, and we've got another 2 repeater clusters, and we're feeding 2 antennas, 2 antennas, 2 antennas, 2, 2, and 2, and then we've got 3 and 3, 3 at the end. Now, the reason why we've selected a north end and a south end for the repeater clusters is given the distance. So with such a long distance, the signal does dissipate across the cable. So we're trying to minimize loss here. Otherwise, if we put all the antennas in one area, then by the time we run the cables to this other end, the signal losses are just too great that it's not economically viable. And the next part shows roughly the markup. So this is our predicted coverage. So each of these coverage diagrams gives us about 16 meters diameter, so about 8 meter radius. And the reason why we've predicted so many antennas, or proposed so many antennas, is really based on that more antennas we put on a trunk cable, the smaller the coverage area. However, the other benefit of using more antennas is that we can penetrate into the neighboring rooms. Otherwise, if we actually just use, say for example, 1 antenna instead of these 6, you might have it here. It might have a greater coverage, but then there's going to be a lot of areas where it's going to be nulled out, so you won't have signal. Okay, this is the proposed repeater design. So what we're proposing here is an external panel antenna with leading cable to a splitter combiner, and that serves up to 8 repeaters. So we're feeding a Telstra repeater, which is band 28, which is 700 meg 4G, Telstra B5, which is 700 meg, 50 meg 3G, Telstra band 3, which is 1800 meg 4G. Then we'll do the same thing with Optus, band 28, 700 meg 4G, band 3, which is 900 meg 3G, and band 5, which is 1800 meg 4G. And then we're doing the same thing again with Vodafone. So we're looking at band 5, which is 900 meg 3G, and band 3, which is 1800 meg 4G. Then we have our mobile network combiner. So that combines all of these signals from the repeaters, and then we have 4 trunk cables going out. So the reason why you'll see varying antennas on these is really just, it's based on the diagram that we just saw before. So some trunks will have 2 antennas, 1 antenna, or 3 antennas. So we'll go on to the next one. So that's CL1, so cluster 1. Just to give you an idea, I'll go back to the markup, and there's CL1, and you'll see cluster 1. So you can see there's a single antenna, and then there's the 3 sets of trunks with the 2 antennas on them. Okay, and I'll just scroll down again, and that concurs there, 2, 2, and 2, and single. Then we go to the next floor. Second cluster, which was still on the north end of that floor. And we go to the next one. So this is the southern end of that floor. So they're pretty much all the same. And then we go to the fourth cluster. Now I'm just going to quickly home in. So we've got here power management, battery backup, and PC comms management. So what this is all about is that we have a power trunk cables going to the repeaters, and they can be automatically or remotely managed, switched on and off. And battery backup, so the power supply that we're providing also has a battery backup, so should there be any power failures, the power supply will still continue to provide power to the repeaters, which means that you'll still have mobile coverage in a power outage. The PC comms management, we design this so the repeaters can be remotely managed, and it is important, especially when you've got a project this size, because repeaters from time to time need to be managed for the purpose of any issues that may arise. If the mobile network providers change their signals, then there may be a firmware upgrade. We may need to also do a remote diagnostic to have a look at any problems or faults that may arise, which can be quickly remotely managed and resolved. It also, we have situations where if there's intermittent faults, if the faults just occur sporadically, then we can put these repeaters online and log the data, and then from that information we can determine what the next and best action is going to be. If we didn't have a remote management solution, it could take months to resolve any of these intermittent or sporadic faults. Okay, so this is level 3 markup. So it's very similar. However, given the difference in the floor plan outlay, it was a slightly different repeater structure that's been put in place. So we've actually got 2 clusters up in the north end, and then on the south end we managed to use 1 cluster. And there's our proposed predicted coverage. Here is the repeater design again. So there's cluster 5, cluster 6, cluster 7. Now this is just giving you an overview of the repeater setup. So basically there's our power supply. Now the power supplies that we provide, they convert 240 to 12 volts DC. We can put a battery of any size, so typically say a 100 amp hour battery. So we can have pretty much almost a whole day of operation, or 8 hours of operation off that repeater cluster. We provide Ethernet switch, our own USB servers, DC power distributors which go to the repeaters. And we also put a fuse. So each repeater or each device that's powered by the repeater can be fused. Now the beauty about these power supplies is that they're also web managed and remotely managed. In the event of any issues, we can shut down the whole power supply, we can do a soft boot, and if there's any issues with battery, we get alarm notifications. Alright, now next is an in-building signal example of the measurements that we undertake. So this is Healthscope John Faulkner Private Hospital in Melbourne, Victoria. And after completion of the installation, I'm just showing here basically an example of the dome antenna that's been installed. And we conduct signal measurements just to see and confirm that the signals are being distributed. So at this one here, this antenna, it was a Telstra mobile repeater install. So I've marked up, there's 700 megs, yep, and it was an 1800 meg off that antenna. So, sorry, just going too quickly there. Okay, and so we conduct these measurements off each antenna just to confirm everything's operational and as it should be. So we also do a post report. So once the installation is complete and commissioning is done, we do post measurements, and we can do as built reports, and that also confirms that the system is operational. So this was part of a report that was sent to Healthscope. So as you can see here, photos illustrated above to confirm Telstra repeaters on levels 1 and 2 are active and at good level. And there's the frequencies that were relayed, 778, 887 and 815 megs. And the date that we conducted the measurements. Now this is the proposed antenna design for Prince of Wales Hospital. So I proposed panel antennas. These are quite small. They're about 300mm by 300mm, and they're directional. And we want to use directional antennas so we can concentrate on receiving and transmitting as much a signal as possible back to the network cell and minimizing interference to surrounding network cells. The benefit of these antennas is because of their size and scale, we can easily put 3 on a pole and achieve minimal wind loading. So I'm just illustrating here the the number of masts that need to go up. So I'm just going to scroll out. So it's 1, 2, 3 masts. There's the antenna specification. So it shows the details of this antenna, which is an Israeli made antenna. It has very good performance and it's IP67 rated, which means in layman's terms that it's waterproof. The internal antennas that are proposed are the dome antennas from PowerTech. So there's the specifications for that. So these antennas are designed for this type of work, and they'll happily work with the repeaters that's been proposed. This is the cabling that we're proposing. So it may be a combination of LMR 400 and Heliax. So I'll move on to the Heliax, and that's the LD4-50A. So the Heliax is generally used for the long trunk runs, and that's internally in the building. So I'll just go back over. So the Heliax are these cabling here that's running out to the dome antennas, and then the LMR cabling will be these cables from the antenna leading in. And the purpose of using Heliax is it's far more less lossy compared to the LMR. LMR, we find it generally works well for leading because we get such high signal levels from the rooftop, and so we don't really need to have really high grade antennas, high grade cabling. However, there are times where we have to use Heliax runs depending on the signals that we're relaying and the length of the runs and how much how high the signal levels are. Okay, so next we're going to move on to the power supply. So I've also provided some specifications on the power supply. And that's it. If there's any other questions, please feel free to contact me or PowerTech, and we can discuss further. Thank you.